Hello guys, welcome to our MHCET mathematics section. We are taking a new topic today, that is matrices. So let us first of all discuss what are the things which you have to recollect in this chapter and what are the sums which are typically asked in this particular chapter. So let us first discuss what is a matrix. So matrix is any representation of a set of numbers in rows and columns. It is basically the arrangement of numbers in rows and columns. It is denoted by a capital letter. So like over here A is equal to Aij. So Aij is the term at the position ith row and jth column. And my M and N are number of rows and number of columns in that particular matrix. If my M is equal to N, then that matrix is called as a square matrix, like 2 by 2 or 3 by 3. If N not equal to M, then it becomes a rectangular matrix like 3 cross 2 or 2 cross 3. If M is equal to 1, then it becomes a row matrix, and if N is equal to 1, then it becomes a column matrix. Now this is called as an identity matrix, which is of order 3. You can have order 2, order 4 and so on. So basically you have to remember that the diagonal elements in a matrix, this particular elements are called as the diagonal elements. So for a square matrix, this becomes a diagonal element. If my diagonal elements are basically 1, then that becomes a identity matrix. Apart from those diagonal elements, all the other elements are 0. Now this is called as a upper triangular matrix, in which I first of all define the diagonal. So this particular elements are the diagonal elements. If the numbers above the diagonal elements are present and below are all 0, then that becomes a upper triangular matrix. Otherwise it becomes a lower triangular matrix. Like if I am having the diagonal elements below are present but above are 0, then that becomes a lower triangular matrix. Next we are discussing the operation which we can do on matrix. First of all, if we are equating two matrices, then in that case you have to take into consideration that they both have the same order and each and every element of the matrices will be equal to each other. Like the first element of A will be equal to the first element of B, second element will be equal to the second element, and so on. If you're adding or subtracting the two matrices, then again you have to consider the same condition that they have same order, and then you will add the corresponding elements together. That is, you will add the element which is at first position with the first position element in B, and so on. If you are multiplying a constant with a matrix, then you have to multiply the individual elements present in that matrix with that constant. If you are taking a transpose of a matrix, it basically means that it is changing of rows to columns and columns to rows of a matrix. So you will have these properties, that is a transpose of a matrix will give you the original matrix. If you are adding two matrices and taking a transpose, it will be same as taking transpose of them and then adding the two matrices. If you are multiplying a constant with the matrix and taking the transpose, it will be same as taking the transpose of the matrix first and then multiplying with the constant. If you are multiplying two matrix and taking the transpose, then it will be a multiplication of B transpose into A transpose. So basically the order changes over here. Now let us see how to multiply. Whenever you are multiplying two matrices, like in this case I am multiplying A into B. So where A is M cross N and B is N cross P. In that you have to take into consideration the first important thing, that is the number of columns in A should be equal to number of rows in B. That is very much important condition which you have to satisfy, and the net resultant matrix which you will be getting will be combination of the rows in A and the columns in B. So you will get a matrix which results into a M cross P. Now how do you multiply? Whenever you are multiplying, you will multiply the rows of A, that is the first matrix, into the columns of B. So you will multiply individual elements present and then take the sum. So you will get the first element from it. If you want to go for the second element, you will multiply first row with the second column and add the products which you are getting, so you will get the second element, and so on. So this is how you find the product of two matrices. Next we are defining my determinant of a matrix A. It is denoted by dit or a modulus sign. If my determinant is not equal to 0, then it is called as a non-singular matrix. If it is equal to 0, then it is a singular matrix. Now next we will be defining inverse of a matrix. So if I am having a product of two matrices and I am getting an identity matrix, then the other matrix is called as the inverse of that matrix. If my determinant of A is equal to 0, that means my A is a singular matrix, then in that case my A inverse does not exist. Then if I am having a product of two matrices and I am finding the inverse, then it is given by product of B inverse into A inverse. If I am having such equation wherein my A is some matrix and M and N are some constant terms, wherein I have N not equal to 0, then I can find my inverse of that matrix using this particular equation. So next we are defining what is called as a minor. A minor will depend on the element which I am going to consider in a square matrix. So if I am considering Aij as my element, then for that I will have the minor as Mij. So calculation of that is done by calculating the determinant of the matrix by deleting the ith row and the jth column in my A. So once I get that, I can define something which is called as a cofactor. Now cofactor is nothing but multiplication of the term minus 1 raised to I plus j to my minor. So I will be getting a corresponding cofactor for a term Aij. Now once I am calculating Cij, that is my cofactors for that matrix A, and if I am combining all that and forming a new matrix, let us say that it is B, then I can define something which is called as adjoint of A. It is given by B transpose. That means I am taking the cofactor matrix transpose. Now these are the couple of things which you have to remember, because there will be sums which will be asked. So the first important thing which you have to remember is, if I am considering any row or column, the elements in that, and I am multiplying with its corresponding cofactor, like if I am considering A11 and multiplying it with the cofactor C11, plus the next element in that row A12 into C12 plus A13 into C13. If I consider any row like that or a column, then it will be equal to determinant of A. Next one, if I am considering elements of any particular row or column and I am considering the cofactor which are not present in that particular row and I am multiplying, then that value will be equal to 0. Like if I am considering the first row and I am multiplying with the cofactor which is not present in that row, any cofactor which is not present in that row, then this particular addition will give me an answer of 0. Next one is, if I am multiplying A into its adjoint or adjoint into A, I will get the value as determinant of A into In, where N is my order of A and In is the order N identity matrix. Now if I am finding adjoint of a product of two matrices, then it will be adjoint of B into adjoint of A. If I am finding adjoint of a transpose of a matrix, then it will be adjoint of that matrix transpose. Then if I am finding determinant of adjoint of A, then it will be the determinant of A raised to n minus 1. Then adjoint of adjoint will be determinant of A raised to n minus 2 into the matrix A. Next one is finding A inverse using adjoint method. So the formula is adjoint of A divided by the determinant of A. And if I am finding the transpose inverse, then that will be same as first finding the inverse and taking the transpose. Of these, you must remember these particular, because the probability of getting questions based on them is very much. Now whenever you are having any product of AB and it is equal to a matrix which is P, whenever you are having a row transformation, then the row transformation should be done on the first multiple, that is A, and corresponding row transformation will be done in P. So row transformation basically means manipulation of only the rows. You can have subtraction of the two rows, you can have multiplication of any row with a constant term, you can have switching of the rows, and all those things come under my row transformation, and corresponding things can be done in the column transformation. If you are doing column transformation of this, then you should do it on the second multiple, that is B, and the corresponding column transformation will be done in P. So this is useful in considering a problem in which you have to find A inverse. If I have to find A inverse, then I will consider this equation wherein it is A into A inverse is equal to I. So if it is A into A inverse, then I have to go for row transformation. Now the steps to follow are, first of all, you have to make this particular element as 1. Try to make it by any method of row transformation. Once you get it as 1, you make these two as 0. After that, you go for A to 2, make it 1, and using that one, you make these two 0. And after that, you make this 1, and using this, you make this particular 0. So over here, you will have the identity matrix, and whatever row transformation which you were doing on this, corresponding row transformation has to be done on this side also. So you will have this A, the matrix A changed to an identity matrix, and this I will be changed to your inverse matrix. So you will get your directly A inverse. Now if you have a square matrix of order 2 and you have to find your inverse, then you have to simply use this particular equation wherein you first find the determinant. If it is not equal to 0, then only your inverse will be existing. So in the matrix, what you do, you switch the diagonal elements. So you will have a D and a A, and the non-diagonal elements will be replaced with minus sign. This method is only applicable if the matrix is of order 2 and it is a non-singular matrix. So next we will be seeing some problems based on this. Let's go for the first question. So I am having a quadratic equation in my matrix A, where A is given, that is determinant of A is not equal to 0. That is just to tell you that inverse exists. So you have to find what is going to be my value of A inverse. You will consider this equation. Now what you will do is, if my A square plus 2A plus 3I equals 0, in this you will multiply throughout by A inverse. So once you will multiply throughout by A inverse, this A square is basically A into A. So whenever it is multiplied by A inverse into A will become I. You will have A inverse into A into A. So this part becomes I plus 2 into A inverse A plus 3 into A inverse I, which is 0. A inverse A becomes I. So you will have here I into A, which becomes A plus 2I plus 3 into A inverse, because A inverse into I is A inverse, which is equal to 0. Leaving A square, A inverse that on the same side, other things you will take on the other side. So you will get A inverse as minus 1 by 3 into A plus 2I. So basically it's the first option. Next we are seeing it is given that A and B are square matrix such that B is equal to minus of A inverse BA. Then I have to find what is going to be my A plus B. Let us first understand this particular equation given to me. They have given B is equal to minus A inverse BA. So what I do is I multiply on both sides with A. So when I multiply with both sides with A, I will get AB is equal to minus of A into A inverse into BA. So I am post multiplying. So whenever I am post multiplying, I am getting this A into A inverse. So my A into A inverse becomes I, and I into BA will become BA. So what I am getting is AB is equal to minus BA. Now let us consider this equation. So I am having A plus B the whole square. which I can write it as A plus B into A plus B. Now you have to be careful, we are not going to apply the identity which we know, that is A plus B the whole square. It's not going to be the same thing because this is basically multiplication of matrix. So what you will do is you will individually multiply it, so it becomes A into this bracket, so that gives you A square plus A into B. Now B into this bracket will give you plus BA plus B square. So you know that AB is minus BA, so once you substitute this you will get it as minus BA. So you are having minus BA plus BA, which gets cancelled and you are remaining with the answer A square plus B square. So your right option is B. So next question is, if A is given as a diagonal matrix or a scalar matrix in this case, then I have to find the value of determinant of A into determinant of adjoint of A. Now I remember that determinant of adjoint of A is given by determinant of A raised to n minus 1, where n minus 1, that n is basically the order of A. So I will get it as determinant of A square because it is 3 minus 1. So the value of this basically will be A square, determinant of A square into A, so that is determinant of A cube. So I have to find basically determinant of this. Now since this is a scalar matrix, the determinant will be defined by the terms which are involved, that is the diagonal terms which are involved, multiplication of that. So I will get determinant of this value as A cube, that is determinant of A is basically A cube because it is just multiplication of all the diagonal elements. So my value for this will be A cube the whole cube, which is nothing but A raised to 9. So your right answer is A raised to 9, that is C. The next one is, my A is given to me as a 2 cross 2, that is matrix of order 2. Then I have to find 19 into A inverse. Now the formula for A inverse is 1 by determinant of A into adjoint of A. Now whenever you are having a matrix which is of order 2, then in that case to get the adjoint it is very much simple. What you do is basically you consider the diagonal elements and swap them. So you will have the first element as minus 2 and the second diagonal element will be 2. Then what you do is you consider the non-diagonal elements and multiply it with minus 1. So you will have minus 3 and minus 5. So this is what is going to be my adjoint of A. Next I have to find what is going to be my determinant of A. So my determinant of A will be basically 2 into minus 2, that is minus 4, minus 5 into 3, that is 15. So I will get it as so I will get this value as minus 19. So my A inverse is basically, so I will get my A inverse as 1 by minus 19 into this. So if I want to find 19 into A inverse, so I have to basically take that minus sign inside. So this will be plus, plus, plus and minus. So I'm getting basically the original matrix. So answer is going to be A. The next question is related to finding inverse. So what we have to do is we have to find the element in the first row and the third column of the inverse of this particular matrix. So what we do is they have given us that it is going to be first row, third column. We have just discussed what is the formula for finding A inverse. It is determinant of A into the adjoint of A. Now you remember that adjoint of A is basically the transpose of the cofactor matrix. So transpose of the cofactor matrix. So basically if you want to find the element present in my first row and third column of the inverse, then you have to find the element that is a cofactor of that element which is going to be present in my third row, first column. So you have to basically, because you are taking the transpose, that is why you are doing that. So you will find cofactor of the element which is going to be present in my third row, first column. So it's in the third row, first column. So this is that element. I have to find cofactor of this. So the cofactor of this will be 2 into 2 minus of minus 3. So that is why I'm going to get the value as 7. Now you have to find the determinant of this, because you remember that inverse, while finding inverse, you require the determinant also. So if you take determinant of this, you will get it as 1 into 1 minus 0, and 2 into 0 and 3 into, you will get it as 0. So basically you are getting the determinant as 1. So that is why your element is 7 only. So if you had a determinant which was not 1, if it was like 7, then your answer would have been 1. But since it is coming as, the determinant is coming as 1, so you will get the answer as 7. So the next question is, you have to find f of x, they have given f of x as this, g of x is given as this, then you have to find f of x into g of y's inverse. So you remember that a into b inverse is b inverse into a inverse. So basically you will get it as g of y inverse into f of x inverse. So let us try to find what is going to be the inverse of g of y and f of x. Now whenever you are having a matrix of this form, like you are having cos x, sin x, cos x and all those terms, and a 1 in a row and a column, then whenever you have to find inverse of that matrix, then it is just replacing the x with minus x. So you will have this as cos of minus x minus sine of minus x, sine of minus x, cos of minus x. So whenever you are having a matrix which is given in this format and you want to find inverse of it, then you have to simply replace the x with a minus x. So you are finding g of, in the same way, in this also you can see that there is cos, sine, and there is a 1 which is present in a row and a column where other elements are 0. So whenever you are having a matrix like this, the inverse of this will also be replacement of my x with minus x. So in this case it's going to be replaced with y, because we have to find g of y, so it will be replaced with minus y. So your equation, this formula will be basically g of minus y into f of minus x, which is basically your third option, that is C. So these were the problems which are mostly asked in this particular chapter, that is matrices. I hope the tips were useful. I hope you will be able to apply those tips wherever required. If you have any doubts regarding the solving part or the tips, if you have not understood, you can just comment below. I will be responding to those comments accordingly. So thank you for watching. Please share this video with your friends so that they are also helped with the tips which are being given over here. Please subscribe to our page so that you get regular updates on the uploaded videos also. You can also watch other videos which are related to engineering, and happy learning. Bye, all the best.